Good day, ladies and gentlemen. Welcome to the How to Get Started in Cybersecurity. My name is Wayne Burke, Vice President of Cyber2 Labs, and it gives me great pleasure and honor to be delivering this webinar for you all. The agenda for today will be a quick introduction about myself. We'll then be discussing the knowledge, skills, and abilities, the foundational skills that we really want to focus on, some of the best progressions into the cyberspace. We'll look at the crucial skills that you need to get the jobs and some of the real world tips from experience in that. I've been in the industry since the 1990s, and we'll be talking about the value of certifications when backed by practical examinations, and we'll be finally finishing off with a Q&A session. So a very brief overview of my background. Really what gives me knowledge to be bringing you some of this information is that I've been in technology since the 1990s. One of my first computers when I was still a kid was a Commodore 64 ZX Spectrum, and I've done many different certifications from Microsoft to Cisco, Unix, Linux, and I'm also currently a Master EC Council instructor, as well as a past author for the EC Council original CAS, which was the Center of Advanced Cyber Training, and it was developing the advanced mobile hacking and forensics. So we specialize in artificial intelligence, drones, forensics, defense, hacking, decoys, IoT, and any other type of electronic device. For us, we want to also pass this information forward by educating and helping others to also educate themselves. As John Allen Paulos once said, uncertainty is the only certainty there is, and knowing how to live with insecurity is the only security. Well, very true statement. So without further ado, let's jump into the fact that there's a huge skills shortage for skilled cyber professionals. Now, when we talk about skilled cyber professionals, we want to be clear here. We're talking about people that can actually do the job. We're not talking about people who have got a piece of paper that have given them some sort of certification, right? So that's the part where certifications don't guarantee you can actually do the job. Unless, of course, many of the newest certifications that have actually got a hands-on practical exam section, that's obviously going to be giving you more confidence knowing that you've actually got the skills, the knowledge, and the abilities effectively. So as you can see, just looking at some of the simple Google searches, you can see how many companies are still pointing out the huge skills shortage, and that's because the fact that there might be a lot of qualified people, as I've mentioned, but do they actually have the skills to do the job in cybersecurity? So there might be an IT person, but the skills needed in cybersecurity are going to be way deeper. You're going to have multiple different facets of the same skill, as we'll be getting into. So as that very important statement there, give me someone who has the right attitude, behavior, and communication skills, who knows how to learn and wants to learn. That's the key point. Many people in IT might be veterans in IT. They've been doing networking for the last 20 years, and now you're going to try and incentivize them to learn cybersecurity as though they love it, like it's their passion, right? So yes, that's going to be a little bit more challenging because a person's already been in cybersecurity, at least been in IT, but now they want to move into cybersecurity, right? So this is where we want to try and incentivize the younger generation to get the basic skills they need in IT and talk about what skills are actually needed, and then what's going to be most crucial in the specialization field in cybersecurity. There's multiple different areas, of course, and that's where we're going to talk a little bit more about. Now, when we talk about foundational knowledge and the skills and the abilities, that means you've got to have the skill to basically take a computer apart and rebuild it. You need to know what a hard drive is. You need to know what the motherboard is. You need to know how to flash the BIOS, as it was called in the good old days. We now typically refer to that as the firmware, or the we won't get into the specific acronyms at this point, but we'll just call that the general firmware, right? So your BIOS was the original basic input-output software or system that was a mini operating system that would run on the chips And so one of the first things you do before you actually loaded the actual operating system on a hard drive, like Windows as an example, you had to make sure your BIOS had all the latest information, where you would then be plugging in all the different types of peripheral. And so this is a key point where we started looking at computers and we speak about transistors and binary. This is a quick video that's going to give you a little bit more insight into why it's so crucial to understand both the software and the hardware, so we truly understand how computers communicate by the language they speak, being zeros and ones, and then how they send that information across the internet, as an example, or across the local network. So without further ado, let's take a look at why do computers use ones and zeros. So binary and transistors are going to be explained in this wonderful YouTube video.
It's a common theme throughout the modern world that everything in a computer's brain comes down to ones and zeros. You've most likely heard that this code of ones and zeros is what's referred to as binary. And while almost everybody knows that this is somehow related to what computers do, very few of us seem to understand what binary is or why computers use it. If you want to know, then this video is for you, because it's actually a very simple concept and still quite fascinating. Before we get to computers, let's talk about what binary itself is, as it existed long before computers did. Binary is nothing more than a system of counting. To understand how it works, let's look at two other systems of counting, tally marks and the glorious base 10 positional that we all know and love today. Tally marks are the simplest counting system imaginable. However many things you have, you put down that many marks, easy as pie, but not very efficient. Meanwhile, base 10 positional, which is what we use today, uses a different symbol to represent different amounts of things. With the numbers 0 through 9, we can recognize that each symbol indicates a different amount of things. If we need to represent something higher than 9, we add a digit to the left, roll its first digit back to 0, and start over. This system is very efficient compared to tally marks because each digit we add exponentially increases the amount of things we can represent. Because in this system we add a new digit every 10 things, each digit represents an increasing power of 10. This is the number of ones we have, the number of tens, the number of hundreds, the number of thousands, and so on. Now this is probably something you already know, but it's very important to keep it in mind when we talk about binary. Now binary works the exact same way as base 10 positional, but instead of each digit going from 0 to 9, it goes from 0 to 1. Counting upwards in binary sounds like this: 0, 1, 10, 11, 100, 101, 110, 111, and 1000. Because each digit of binary has only 2 values and not 10, each additional digit represents an increasing power of 2 rather than an increasing power of 10. So this is the number of ones we have, the number of 2s, 4s, 8s, 16s, 32s, 64s, 128s, and so on. Not nearly as efficient as base 10, but exponentially more efficient than tally marks. Literally. So now that we know how binary works, let's talk about computers. Why did the first computer creators, as wise and intelligent as they are, waste their time with such an ineffective system of counting? Well, it's because of a physical limitation on how computers work. Everything a computer does comes down to what's known as microtransistors. Simple, tiny, eensy-beensy little switches that can either be on or off and can be flipped on or off with a very weak electrical charge. The first goal was to get computers to count. And to get them to count by using these switches, we could use the tally system, meaning the number of on switches equals the number of things we have, or we could use the much more efficient system of binary, where each switch represents a digit of binary. 8 transistors using the tally system could represent a number as large as 8 by turning all of them on. With binary, we can represent a number as high as 255. An on switch means a 1, and an off switch means a 0. Now is a good time to mention that a single transistor is what's known as a bit, which stands for binary digit. A byte is 8 of these bits in a row, which means any number between 0 and 255. So if binary is just a system of counting, what do people mean when they explain how to spell things in binary? Well, what they really mean is how to spell things with ASCII. The American Standard Code for Information Interchange is a way to convert a computer's data, which can only be in numbers, and turn it into letters for humans to have an easier time to work with. ASCII simply assigns a character to each value represented by a byte of binary. Now because a byte has 8 digits of binary to work with, and 8 digits of binary can represent up to 255 values, ASCII had 255 letters and symbols to choose from, more than enough for the entire alphabet, punctuation marks, and other symbols. For example, the corresponding ASCII number for an uppercase A is 65. Now 65 in base 10 is equal to 1,000,001 in binary. So whenever you type in an uppercase A in a word program, a coding program, or a scripting program or whatever, somewhere there's a little tiny row of 8 transistors arranged in the pattern of off, on, off, 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 on, which represents 0, 1, 0, 0, 0, 0, 0, 1 in binary, which is interpreted as 65 in base 10, which is converted by ASCII into an uppercase A. You're likely starting to get a feel for the staggering amount of transistors required to write something as simple as a Facebook status, let alone all the different coding that your computer has to do to make the screen light up, play games, calculate massive values, and so on. Well, long before we got to the point where your phone can play 3-dimensional games, it became clear that numbers as high as 255 just weren't going to cut it. Regardless of how many bytes we had, and it was a lot, even adding 4 fully active bytes together could only get a number as high as 1020. To solve this problem, new computers were designed to recognize 2 bytes as one single number. So now instead of referencing one line of 8 transistors, computers could reference 2 lines, giving 16 digits worth of binary. This was a huge help because it increased the amount of representable numbers exponentially from 255 up to 65,535. When you hear people talking about the difference between 8-bit and 16-bit, this is more or less it. Now that doesn't mean that a 16-bit system is exponentially that much more powerful, because your program isn't always going to be utilizing all of these numbers in each byte that it represents. It just has the option to, which opens up lots of doors. Well, this could go on for ages and ages, but I want to end this particular video right here so as not to be overwhelming. In future videos, I will explain how computers use these numbers to decide which pixel is what color on your monitor, what the different components of your computer are for, and how hard drives store binary digits on a spinning disk rather than in transistors. Thank you for watching, and if you enjoyed this video, liking and subscribing is always a huge help. While I've been enjoying making these instructional videos, I might move them to a different channel soon and continue doing comedic gaming.
Alrighty, so now that we watched that interesting YouTube video, we now want to take you into the basic practicalities of this. And this is the point where you got to realize we need to know IT. Before we can go into cybersecurity, we need to have a very, very thorough understanding of computer hardware, computer software, and networking. So these are some of the things that you're going to have to do in the role, let's say, as a digital forensics investigator. You're going to have to manually go in sometimes and look at carving out forensic evidence, which might be left in between, you know, a Word document that may have been partially deleted. So you're going to have to go into the binary data. So let's go into creating a simple text file, and then I'll go along and show you how to view the text file with a hex editor, a hexadecimal editor. Right, so I'm just using a simple Raspberry Pi with a Raspberry Pi operating system. This is Linux Debian, basically. And we're going to go in and simply go along and show you pwd, print my working directory. So I'm in the home Pi. Now I'm going to go along and say, well, I want to go and create a new directory. So I'm going to say make a new directory, and we'll just call that demo. And then we're going to change to the demo directory. And now we're going to say touch. We want to go and create a new file, and we're going to call this new file hex.txt. So you'll now see if I do ls, that's now just created that blank file, and now I can go along and open up that text or that hex file with a text editor called Nano, or I could use Vi or other editors. Nano is just a simple command line text editor, and I'm just going to go ahead and say hello. So simple Word, Control X, I'm going to save that. And now if I go ahead and do ls, and I had to change that with some additional parameters so I can see more details about that file. There you can actually see the date it was created, time, and some of those other basic parameters. The basics there obviously telling you the total size as well, but we want to look more specifically at that binary information. So now we're going to go along and use the built-in hex editor. So if we wanted to find out more details about this command line program called XXD as an example, we could use the man, short for manual, XXD. And not all applications have a manual, but very many times and often they do. So here we can actually see the information about the built-in XXD application. It enables you to make a hex dump or do the reverse. And as you can read there, the description, it creates a hex dump of a given file or a standard input. It can also convert a hex dump back to its original binary form. So we can actually use XXD when working a lot with binary and a lot of different types of resources on a computer system. You can of course go along and read more about this. So we can just Q to quit that. And that was just giving you some basics of, being able to work things out. So you may not have used the XXD for maybe 20 years, but if you have to learn it on the job, you can go along and figure it out because there's a manual built in to your operating system, or you're going to be able to go along and use the internet to go and research what the resources are there. So here we'll just go along and say we want to go along and now open up the document we created there with XXD. And there you can see the very basics. This was only one line because it was only a very small word there, of course. So you could actually see this was only on one line, whilst in the PowerPoint there's more text there. You could see it was actually on multiple lines there based upon how much space it's going to be storing on your hard disk and other factors that we won't go into in this short quick demo. But there it was, just giving you some simple examples of having to be able to work with command line things is crucial, and then also know how to work things out when you're looking at the binary and hex in a computer system. Let's speak about level 1, and we want to talk more about the hands-on experience we could gain using various hardware, software devices. So this is where you got to understand, before you look at cybersecurity, you need to know how to build a computer. Because as an example, if you're going to go along and look at penetration testing, ethical hacking, if you want to break into the computer system, you need to know how it actually functions. How do you build that house that you want to break into, as an example? So things like flashing, updating the firmware, the EFI, your extensible firmware interface, as it's now called, instead of the good old BIOS or IoT. And then you want to look at building a small physical network for testing, where you're actually going to use a 4-port or an 8-port switch, and you're going to actually connect some older machines. So a Raspberry Pi, ask one of your friends if they've got older, 10-year-old machines that's got an older operating system, but you're going to be able to still network even with that older operating system. So once you've built those things physically, then you can start looking at the virtualization. And so basically, you don't want to try and understand and learn virtualization when you haven't actually built the physical environment, like the physical operating system and then the actual networking components. So you're going to look at setting up things like DHCP, DNS, your routing or your routing functionality. And so this is where you're going to get a lot of experience installing and uninstalling Linux, Windows, Apple, Mac, all different types of the popular operating systems. And then after doing the physical computing like desktops and laptops and so on, you've looked at Raspberry Pis, then you want to go along and look at cell phones, tablets, and their operating systems, so Android and Apple. And then you want to look at the basics of learning how to do things like rooting or jailbreaking, where you want to basically gain root access. You want to gain full administrative access of that device so you can test your operations, your applications, your networking. And then, of course, once you've got a jailbroken or rooted device, then you have full access to the actual code. So if you're learning the coding on mobile applications as an example, then you have the ability to go in and actually look at the client application and the code that is obviously building that client application. You may be doing a security assessment where you need to find out if the security authentication from the cell phone application to the back-end servers is adequate. Those are some of the examples of why you're going to need to have some of these fundamental level 1 hands-on skills with general hardware and software in IT. In this next demonstration, we're going to be taking you through flashing the IoT firmware, and we're going to be using that Raspberry Pi operating system. It's running Debian Linux. Right, so here we have an example of a Wi-Fi IoT module that we're going to be flashing with a custom firmware, and this is known as the ESP8266 chip. This one specifically has 4 megabytes of memory or flash, and if you go down to the sparkfun.com, that's just one of those products. Now you can also go along and use a different manufacturer that's got a different form factor. As you can see, these boards, basically the D1 Mini, also has 4 meg of memory. So there we can see some more of the technical specifications of this specific device. And the major difference here is this has just got a different port connector, so a Type-C USB port, whilst the other cheaper Wi-Fi module, you actually had to plug it into a breadboard. As you can see, the actual pins that you then have to put it onto a prototyping board or a breadboard, as we will be talking in other sessions. So what we're going to be able to otherwise use is the actual Amazon little product over here. You can see it's a USB adapter, which simply allows you to take your IoT chip and plug it into this UART programmer or FTDI programmer. So you'll see we'll be talking more about those in full-blown courses that are on offer for EC Council. So again, this is a cheap $9.99 little device that gives you both the ESP8266 chip as well as the actual USB board. And it looked like that's now also upgraded to 4 meg of flash as well. And then if you just go and look at more of the technical specifications, you can get more details. So as I mentioned, this is the one that's got upgraded. They normally had 1 megabyte. Actually, it was, with the really first ones were like only 512 kilobytes of RAM. So not even 1 megabyte of RAM. But now we can actually see that's been upgraded to 4 megabyte. And the specifications is 802.11 B, G, and N. That's basically the specifications and the frequency and the protocols and all the capabilities of the actual device. And there you can see some of the other components that you could then add on to build some of your IoT projects. But what we're looking at today is simply flashing the actual mini operating system that'll be running on this device. So whether you've bought the chip from SparkFun or you've purchased it through ESP folks, they are using all the same actual chipset, the ESP8266. So we want to go ahead to the ESP documentation, and we want to get all of the core software that we need to install in order to do the actual flashing. So I've already gone ahead and done the actual install. You can see it's very straightforward, not difficult to obviously go ahead and do. And for those of you that are developers, you're going to want to go along to the GitHub and rather go ahead and install the dev version of the actual tools. So if you've gone ahead and installed the actual developer version, we're going to be using the simple esptool.py TAC-H for the menu output. And then that way we'll be able to see the other specific syntaxes that we can actually use with the actual command line tool. And so there you can see these are all the different switches that we need to use if we want to read the memory, if we want to write the flash. So we've got a lot of different switches that we can actually utilize. So once we've set up our basic ESP tools that we need to do the actual flashing, the next thing to get you all interested into cybersecurity would be to allow you to build your own IoT cheap, affordable Wi-Fi hacking platform for testing and learning. And I bring you Space Hun Tech. This is, again, open source project. And you can go and read more details. You can see they've got a version 3 in the pipeline. But for now, you can see all the version 2 capabilities and even down to the very in-depth installation guide on their wiki. So all the details you need to actually go along and build this, including the exact instructions for, as you can see, flashing the actual firmware. So using the ESP tool and there you can see an example of the actual command that we're going to be using. So very helpful information is always available for us. We just need to know how to go along and get that information. So if we had to go along and copy that exact command, all we'd need to do is download the correct bin, the binary file, and then we'll be able to run the actual flash-in command with just changing the last name before the .bin. So let's go ahead and do that. So like I said, if I just copied that command and pasted it, well, there's a few things. First of all, when we plug in our device, we want to make sure we know what the actual dev TTY USB number is. We want to verify that it is the TTY USB 0. And to find that out, we can use many different utilities, but we'll keep this simple and just use the daemon message. And you need to be running this as root. So you need to use the superuser_do command for D message. And that means you need to obviously have the root password. And there we can actually confirm more details about the actual UART converter board that we're using. You can see the specific chipset details, and it's now attached to the TTY USB 0. So we've now confirmed that everything is plugged in, the physical IoT chip is plugged in, and we ran that previous command, but we want to now go ahead and ensure we've downloaded one of the actual SpaceHun images for his Wi-Fi deauthor testing solution. And so it all depends on the actual physical chipset you had, like we were showing you the example of using the Wemos D1. So if I go ahead and right click and say copy that link location, I could then go along and download that file. And a very quick and easy way to do that in Linux would just be to go ahead and say wget for webget, and then the full path to where that file is located. So once you've downloaded that file, some of the times I do things incorrectly to make sure people are paying attention, and that's where we go like, well, we're trying to just download this file, but it's telling us permission denied. So some of the commands are going to require that you run the command from a command line terminal like we're doing right now as a root or the actual main big boss of the operating system. In Linux, we call that the root privilege. In Windows, we call that the administrator role or privilege. So here we'll do the same command. We'll use arrow up to go back to the previous command, and here we're just going to go ahead and add the sudo before that. So we can run this command as root. And so now it's going out, connecting to that, and it's now downloading the file. So once it's downloaded the file, we're now ready for the next step. And so now all we needed to do was literally change the name. Went a little bit too far. All we needed to do there was change the name to whatever the name of the file is that we just downloaded. And we should be able to now flash the actual IoT firmware, where it will then be ready to be plugged in, and you'll be able to continue with your IoT security project. Now it might take a minute or so. So without us having to wait till it gets to the full 100%, of course, I'll just pause the video and we'll make sure we get that confirmation that it did flash the actual IoT chip successfully. All right, so now it's finished the flashing and we can see it was all verified. So we got the hash of the data verified, and now you could unplug it, plug it into your power bank or into your USB computer port, and then you can then continue with your IoT project. So in summary, we showed you the SparkFun IoT chip, the ESPTool website and the documentation, the GitHub for the ESPTool.python, and this is where you're going to see later on, in order to be able to do a lot of this, if we have a problem as an example, we would then be able to go along and actually look at that Python file to see what may have caused the problem or what might be crashing that. So we could go along and view the actual source code. So there we can just use a simple text editor to go and view that Python source code, and that's going to help you do a lot more of the troubleshooting. So again, having skills where you understand the software, you understand the hardware, and you understand the networking and also the programming, the fundamentals of even just doing basic Python programming. And there's just so many things you can actually do with Python when it comes to scripting and programming things. It is just an amazing language for us to be able to actually learn. That's not where you have to actually become a seasoned developer, but you need to know how to actually understand code and scripts. So we looked at the ESPTool Python file. We spoke about the D1 Mini that was giving you a slightly different form factor for that ESP chip set. And then the website for Expressit is showing you the actual more in-depth details of what you can actually do with ESP8266 platforms. So there's a lot of different resources available. We also showed you an example of what device you can actually go ahead and buy on places like Amazon. So this was actually showing you the actual IoT chip and the USB carrier board for a little less than $10. And then we finally showed you a project where you can go along and follow from SpaceHun, where you can go along and build your own Wi-Fi deauthor testing solution. So great results where you put the time and effort in to go along and build things. That's when we're actually learning, when we're going through and actually building it. The next section, level 2, where we want to gain hands-on with networking. So first build the hardware of networking. So use real switches, real routers or routers. And once you've done the physical hardware-based networking, then you go along and you can build the same physical network you just built by using multiple switches and routers and multiple subnets and so on. You can then go along and build out that segmented network using virtualization technologies like VMware Workstation or the open source free Oracle VM VirtualBox. So once you've learned how to build that both physically and virtually, then you want to learn to use packet sniffing and packet crafting, where you're going to be sniffing the network traffic looking at TCP/IP. Once you've done that, you can look at building maybe a small Raspberry Pi router and firewall that has multiple Ethernet ports by using a USB Ethernet adapter. You've got 4 USB ports there, so you can set up multiple different Ethernet adapters by using the USB ports, so you can have a multiple port router as an example. And then look at merging your physical and your virtualization. So connect your physical Raspberry Pi that you set up routing functionality and connect that to your existing virtualization environment, allowing you to merge the hardware and the virtualization. And then, as we mentioned before, install the different operating systems, which we would have all done. But once you've installed all of that, then you can go along and network them all so they all collaborate in the same local network. So level 2, hands-on with networking. Remember, spoke about the hardware. Now we want to give you a demonstration on the virtualization, where we're going to show you basic network segmentation, where I'm going to use the open source, free to use otherwise, the Oracle VirtualBox software. And then I'm going to demonstrate a network packet capture analysis. We'll be showing you the basics on using a command line tool and then showing you the binary. And then you can go along and look at the tryhackme.com or the EC Council cyberq.eccouncil.org, where they've got an entire advanced cyber range, instructions and everything you need in one place. And this is the Oracle VM VirtualBox Manager interface. So the first thing I want to do is go into the File, Preferences, and go down to the Network section. So this is where I could go along and add additional NAT, Network Address Translation Networks as an example. And of course, we can go along and create additional topologies based upon changing other parameters on the actual virtual machine itself. So this is where you can set up more local host networks as well. But like I said, in order to better understand the virtualization and the networking specifically for virtualization, you need to know how to have done it first by building the hardware elements. So building the actual Raspberry Pi, let's say, where you're installing the actual network services. And then you're going to go along and do it where you're going to use a standard router or a standard router. You know, those wireless access points that come with a switch and routing and routing features built in. So, of course, the audience may be from all geographical locations. So, growing up in multiple countries, in Europe, you generally say routers. And in America, you generally say routers. So I've grown up in multiple countries, and that's where we're just making sure everybody's following the terminology I may be using. So here I could simply go along and add a new network adapter, and then I could double click on that new NAT network adapter and change some of the parameters like the classless inter-domain routing, where you can actually create your actual subnet ranges where you could then have those collaborate. We'll set up your networking or dynamic host configuration protocol. and then also specifying if you're going to be using IPv4, which is a 32-bit TCP/IP addressing system, whilst IPv6 is the 128-bit addressing system. So IPv6 allowing much greater scalability and a lot more IP addresses, meaning every device that connects to the network normally has an IP address. So IPv6 is going to allow for a lot more addresses to be used. And then you can also go along and actually click on the port forwarding, which will be showing you how to do some of this port forwarding using IP tables in the next demonstrations. So this was a quick rundown of showing you the basics of virtualization and setting up custom network topologies. So I'm going to always go along and clean up after the fact because I've still got a virtual machine running there, and at least you can then undo what you just went along and did. And that's some of the beautiful examples of how you can actually use your virtualization, combining all of those. As you can see, I'm running Google Nexus 5, which is a virtualization of Android operating system, and I'm running an array of other different operating systems in that virtual network. Level 3, hands-on with operating system administration and basic defense. So you want to go along and look at using Windows operating systems and hardening the actual system. You can find a lot of guidelines from Microsoft.com website. And then go through your fundamental system administration tasks and maintenance, like creating new user accounts, setting the age on the password that could be used. And this is where I was saying we can use our operating systems that we built earlier on and the physical network and the virtualization. So we can now combine all of these elements so we can test everything to ensure they all function in a networked environment. And level 3, hands-on with some of the operating system administration and defense. What I'm going to be demonstrating is how we can set up a TCP port redirect using IP tables in Linux. And you're going to see some great website resources there, as you can see in the slide. So do take note of those. And we're going to start off with a quick overview of IP tables. So there we can see a great tutorial, which is from a Dutch website. And you can see some of the basics, the introduction to the IP tables firewall. So there he goes on to speak about the different components, the enemies, the friends, bogus packets, always allowed packets, and then your typical performance in Linux. So great network topology diagram. And that's showing you the packet flow through the IP tables firewall. And then just some of the very basics of how you can go along and set up some of the configuration, which I'm about to take you through. So many articles exist, like this one over here showing you 25 useful IP table firewall rules every Linux administrator should know. And you can see there's hundreds of these different tutorials available. So this is where we've got so much information on the internet that we can go along and be practicing this all for free. So there as an example, if you want to go along and check your existing rules, you can run some of those commands. So I'm going to go through one or two examples there. And here you can see how you could go along and block a specific IP address in IP tables. So they're very important there, looking at the basic IP tables manual. There are 3 types of tables. You have your filter, your NAT, and then your mangle. And I'm going to go through showing you an example of the NAT in a bit. But there you can see how you can actually use the filter, which is your default table, which contains the built-in chains for your input, so packets that are destined for local sockets. Your forward, those are packets that are routed through the system. And then your output, packets generated locally. So in my example, you'll actually see I'm using a default installed Raspberry Pi operating system. And if I go along and just try to run the IP tables, the check for what current rules exist, it's not even installed by default on a Raspberry Pi. So first thing I'm going to do is install IP tables by using the apt command, your advanced packaging tool command. So apt install IP tables. I'm just going to select yes to install those packages. So now that I've done the install, now I can go and check at the status of what the current rules are. And there we can see basically default configured. All right, so let's say I want to go along now and add a custom rule. I'm just going to add a rule that will be specific for your NAT table, and then we're going to be able to go along and specifically view the NAT table rule. So here I'm just going to go ahead and say I want to use the table NAT minus A pre-routing, the protocol TCP, destination, port 80, and then basically also any port 80 traffic, I want to redirect that to, let's say you had a special VPN server or a proxy server or just a server that had to go and verify and validate certain things. Whatever the case might be, you would be creating a port redirect. So here we would just be redirecting all of the traffic from port 80 onto a different system that might be used for security analysis purposes, as an example. So here I'm going to go along and run that IP tables rule. And then we could go along, and as you could see in this example where you wanted to go along and view the specific rules, remember those 3 tables that you actually have. Here we're going to specify specifically viewing the NAT table rules that we've just configured there. So as you can see, that's just giving you the very basics of how you could go along and configure your networking and your specific firewall rules using IP tables. And for those of you that want a lot more details, remember you can always go along and use the man IP tables. So that's going to give you a lot more details on the IP tables from the built-in manual. And then Q to quit that. But of course you could then go through, continuing to go through this example tutorial where I just showed you the link in the PowerPoint. And of course you can go along and practice your networking and your cyber defense by being a good user and knowing how to actually set up your firewall. So most of the times in Windows, we just trust the Windows to be doing this for us. But of course, when we want to look at diving into breaking into a system, we're going to have to actually look at bypassing or circumventing or finding weaknesses within somebody who set up the IP tables on a server for security purposes, of course. And next, level 4, hands-on with writing code. So we want to make sure we've learned more about the Windows operating system's defense as we've just been going through some of those examples and some of the Linux sysadmin examples too. So one of the responsibilities of a system administrator will be to go along and run maintenance tasks that very often you're going to want to go along and write a simple script to automate some of those system administration tasks. So this is where you can go along and learn some of the basic scripting. You can also use basic functional apps on the marketplaces where you can go along and use some of the free games where you're going to be building mobile apps, basic mobile apps, but you're using the fundamentals of the web and those free coding websites. So those are just some examples of why and what you want to be thinking about when looking at learning to code, so that even if you're not going to be doing much coding in cybersecurity, you do understand the actual how it's written and obviously how to do the initial analysis and so forth. So you don't, walk into a cybersecurity position where you don't understand code. It's not going to be helpful. You need to have a fundamental knowledge of programming, and no better than building things that we're going to be talking about next, where you can maybe program your drone and learn Python programming, where you're going to be learning how to do things that you enjoy building, as an example. Level 4, hands-on with Python specifically. Remember, we've looked at the Windows OS system defense, you've looked at the administration, the maintenance, and now you want to build apps, you want to create networking tools, you want to do scripting for so many purposes. There's an example, amazing book on Python called Violent Python. That's a cookbook for hackers, forensic analysts, pen testers, and security engineers. So it's really going to help you learn to use Python. And then also we have the wonderful Code Red from EC Council, where you can see some of the example courses there. So 11-hour course on deep learning and data science using Python. So those are just some of the example methods that you can actually use for learning. And our next level 4 demonstration here will be actually showing you Python code where we can use that to program our DJI Tello drone. The DJI Tello drone was really developed for educational purposes to really get STEM education flowing. Right, so here we're using PyCharms, and I'm using the almost latest version. As you can see, I'm using the PyCharms Community 2020.3. There is a patch that's busy being downloaded right now, but it is powered by open source software. And here we can see when you've downloaded the actual Python file from the DJI Tello folks, and there you can see the link in there. And so here you'll be able to use the Python wrapper to interact with the Reezy Tello drone using the official Tello API. And you can see the link there for the documentation. And this is just going to be showing us the different elements and the different commands that we can actually use to configure and program our drone to go ahead and do certain things. So this will be the basic command to go along and capture an image. So using the basic code there, you can see while true, image equals drone.get frame read, and you can specify the actual screen resolution size. So that will help you minimize the CPU consumption as well. And then down to some basic movements where you could see I've just programmed some basic movements here. Drone take off, send the RC control, and then basically go along and then land the drone after doing certain movements. And so there you can see I've got the latest update available for install and then restarting. So PyCharms, a great little open source framework. Wouldn't say little, is actually pretty amazing. Right, so yeah, I could go along and just simply go ahead. I've got my project saved, so all of my different components. And that's the beautiful part about this. You can work on all of your different elements within your actual Python project in different components. So you can see each of those individual components and work on them accordingly. Now you might be wondering the reason why we want to discuss the value of practical exam certifications is because of the fact that nowadays so many of the people that have gone for those academic exams, now we're not saying they're bad, but they only test your academic knowledge, your theoretical knowledge. And so many of the companies, they want to know that you've got the skills and the abilities as well. And so that's why you're going to find a lot more of security certifications being practical based. And the CPENT, one of the new EC Council Certified Penetration Testing Professional, it has a 24-hour exam. You can split that up into two 12-hour sessions, but this is the new normal, folks. This is where we realize that we need to ensure we're increasing our skills. So it's all those three elements. Remember, knowledge, you validate that by academic certifications, skills and abilities using a validation of practical exams. So this is where you're going to have to actually do open book, but you're going to have to show that you can use the tools, the techniques, and you can apply everything you learned academically. And then the other side of other types of expectations that you should have is a lot of organizations nowadays to ensure that you are keeping your skills up to date, because we've got a huge shortage of skilled cybersecurity professionals. They're going to have yearly skilled assessment, practical exams effectively, where it's not an exam, but you're going to have to go through and show that you can continuously keep up with the changing needs. Let's say there's been a new version of a special application you've been using that is common for security operations centers, as an example. Right? So those are the things that we need to be really aware of nowadays. In order to succeed, we need to have the skills, the knowledge, and the actual abilities. And so through the session, we gave you an insight into the reason why you want to get the hands-on skills. You want to get that job, you've got to have the KSA, the knowledge, skills, and abilities, ladies and gentlemen. So we looked at some of the fundamentals of binary analysis. We showed you how computers use binary, transistors. So in summary, we wanted to give you an insight into why we needed to better understand the hardware, the software, the networking, the physical networking, the virtual networking, and then having some fundamental coding and or app development skills. So being able to do some basic Python writing or programming your drone, as we went through an example of that. So that was a great example of some of the fundamentals. Before you dive into cybersecurity, you want to make sure you got all your foundational skills so that you can actually get in specifically to security positions where you might want to choose to do digital forensics or network defense or penetration testing, or incident response. There's so many different fields that you can be looking at. And of course, with EC Council, you've got a huge array of educational programs that get you to where you need to be in order to succeed in the cybersecurity industry. All right, so I just want to thank you all for taking the time and effort out of your very busy days, I'm sure. It was a brilliant session for me, and we're going to be breaking out into a Q&A session where I will hand it over to EC Council to be managing the questions, and we'll then be taking it from that point on. Thank you so much again, ladies and gentlemen. Stay safe, and let's get into the Q&A session.